we are going to start another concept, another topic, atomic mass and AMU. Okay? Now, what do we mean by atomic mass? First thing, see, what was the need of atomic mass? First, you need to understand this. See, initially, in ancient time, when atoms were discovering, okay, some chemists were discovering different atoms or different elements, then there was a need to find out the atomic mass of that particular element, isn't it? But the difficulty was that in those times they did not have any sophisticated equipments with which they could measure the atomic mass, which we do today. So, what did they think? They thought that it's better to find out the atomic mass of an element with respect to a standard atom. Okay, it means what? That they, out of so many atoms of elements which we are discovering, they took one atom of a particular element as standard or as reference. And with respect to that, they measured the atomic mass of different elements. Okay, now, but when they were trying to find out which element who should be taken as standard, they jot down some criteria that which atom could be taken as a standard atom so that atomic mass of other elements could be measured with respect to that standard atom of a particular element. Okay, so what were the criteria? The first criteria was that that particular atom of that element should be in abundance. Okay, because if that element is not available in good amount, then there is no use to take that particular atom as a standard element, isn't it? So the first criteria they took was abundance. Second criteria they took was that that particular element should not be least reactive. Means it should not be very less reactive. And neither should be, it should be very reactive. Means the reactivity, sorry, the reactivity of that particular atom should be moderate. It neither should be very reactive nor it should be very less reactive. So what am I writing? Neither very reactive nor least reactive. And third criteria was that that particular atom should not have any isotopes. Because if there are isotopes, what will happen? Then would we need to take the average atomic mass. So no less than 1% and carbon 14 is almost negligible. Means in our nature, carbon 12 isotope is almost 99%. So that is why this carbon 12 atom could be taken as standard because its abundance it is almost fifth abundant element. Okay, neither very reactive nor least reactive, and though isotopes are present, but these two isotopes abundance is very less. So carbon 12 atom was taken as the standard element. Okay, now so this is taken as our standard element. Means our reference with which we will measure the atomic mass of other elements with respect to this carbon 12. Now, how will we define the atomic mass of an element? Okay, what does this definition of atomic mass says? Atomic mass of an element is the relative number. Why am I saying it is relative number? Because it is not an absolute value. I am actually not able to measure. With respect to some standard, I am taking the atomic mass of an element. Okay, so how will I define? I will say atomic mass of an element is a relative number which denotes how many times this particular atom is heavier than 1.12 mass of carbon atom, carbon 12 atom. Okay, I will write down the definition. Mass of an element, atomic mass of an element it is written as mass of one atom of the element by 1/12 mass of one carbon. Which carbon I am talking about? It is carbon 12. Carbon 12 atom. Okay, this is how we define atomic mass. Means it is a relative number and it denotes how many times the mass of one atom of one element is heavier by 1/12 the mass of one carbon atom. This is the definition of a atomic mass of an element. Okay, and I am saying it again that this value is not an absolute value. Okay, it is a relative number. So, after giving this definition of atomic mass, scientists found out that there is a need for a unit to measure the atomic mass because it is a relative number. It is a relative number. Like when we say the mass of a person is, suppose I am saying 60 kg. So what am I saying? How can I say it is 60 kg? That 60 kg is actually with respect to a standard, isn't it? The weight when I go to a shop and suppose I ask the shopkeeper give me 1 kg apples. Then how is he measuring 1 kg apples? He has 1 kg weight and that is taken as a standard. On one side he will keep that 1 kg weight and on the other side he will weight those apples. So it means that is also relative. So here because it is a relative weight, initially there was no unit given. But scientists find out that too there is a need of a unit so that we can find out the actual mass of an element. So to find out the actual mass of an element, there was need to give a particular unit, and that unit is called as AMU. That is atomic mass unit. Okay, so remember what is AMU? AMU is actually a unit given to measure the mass of an atom, of an element. Okay, this is AMU. And how do we define this AMU? Now see, how to define this AMU? What can we say? Now, who was taken as the standard? Carbon 12 atom was taken as the standard. So what did they do? They took mass of carbon 12 atom version will actually help you in numerical skills. Okay, now suppose if I give you one example so that it makes this concept more easy for you people to understand. What am I doing? I'm giving a small numerical. See, 1 AMU, don't have place here. Let me write over this. This 1 AMU is also equal to 1.66 into 10 to the power minus 24. Okay. So, suppose experimentally you have determined the mass of hydrogen atom in grams. Okay. Experimental value of mass of hydrogen atom is suppose given to you as 1.67 into 10 to the power minus 24 gram. Okay, they have asked you calculate the mass of hydrogen atom in AMU. Just now I was telling you, mass of the hydrogen atom in gram is given. You are supposed to calculate the mass of hydrogen atom in AMU. So what will you do? To calculate the mass of hydrogen atom in AMU, what will you do? You will divide this mass 1.67 into 10 to the power minus 24 gram by your standard value. That is 1.66 into 10 to the power. This is minus 24 gram per AMU. I am saying it repeatedly. Okay, this is gram per AMU. So that you will get your mass in AMU. So see what happens. This factor, if you divide, it will be around 1.007888 MU. This is the mass we usually take. Approximately, we take the mass of hydrogen atom as 1 AMU. Okay, but the actual value is 1.007. Clear? So I hope this topic is understood by everyone. What is atomic mass and what do I mean by atomic mass unit? But nowadays, this atomic mass unit is again replaced by U. Means the mass of hydrogen atom in AMU, not in AMU, unified mass, what will I write? 1.0078 U. Okay, this can also be written as U. And what is U? U is unified mass. This is nowadays used. U is unified mass. So mass of hydrogen atom can be written as 1.0078 G. Okay? I hope this topic is clear. We will start another topic, that is empirical formula. Okay? Then writing this out. Now, we have completed atomic mass AMU. Let us start with another topic, empirical formula. Now, what do I mean by this empirical formula? And the definition of empirical formula says the simple whole number ratio of the constant atoms present in the molecule. Okay, what does it mean? What are the steps possible? I said, what is empirical formula? It is simple whole number ratio of constituent atoms present in a molecule of number. Means to each other, we will look into that also. Okay, but a small idea which I am giving you, and what do we mean by empirical formula? It is this simple one-number ratio. If I take one more example, suppose I am taking the example of acetic acid. This is acetic acid. Okay, or we call it as ethanoic acid. So here, what are the different constant atoms present? Carbon is present, hydrogen is present, oxygen is present. These are the three elements present here. What is the ratio of all the three? How many carbons? 2 carbons. How many hydrogen? 3 plus 1, 4. How many oxygen? 2. So what is the simplest ratio now? It is 1:2:1. Okay, so it means if I write CH2O, if I write like this becomes the empirical formula of acetic acid. And molecular formula of acetic acid is CH3COOH. Clear everyone? Now see, when we are actually going to calculate this empirical formula, another term is needed. Okay? And what is that term? Or what is that concept? It is percentage composition. Okay? So you need to know what do we mean by percentage composition. Okay, so what do we mean by percentage composition? Now, here let me take an example. Example of water. Now, what is the total mass of this water molecule? Hydrogen atomic mass is 1, so 2, and for oxygen it is 16. So 16 plus 2 is actually total is 18. 18 gram per mole, which we say that is the that is the molecular mass of this compound, that is water. But I need to calculate the percentage composition. Suppose if I ask you what is the percentage composition of hydrogen atom in water? Similarly, what is the percentage of oxygen? Percentage composition of oxygen in water. So how will I determine that? What is the total mass? Total mass is 18. Out of that 18 gram, how much gram hydrogen is present? 2 gram. So 2 by 18 into 100 will give me the percentage composition of hydrogen in water. Similarly, how will I calculate the percentage of oxygen? For that what I am going to do, out of this 18 gram, 16 gram water is present. Sorry, 16 gram oxygen is present. So 16 by 18 into 100. This will give me what? This will give me my percentage composition of oxygen present in water. Okay, here you can do one more thing. You have calculated this factor will be around 11 point something, isn't it? And next what you can do is total percentage will be 100. So from 100 you can subtract this, you will get the percentage composition of hydrogen. Okay, I will stop this here today. Tomorrow